Welcome to section 12.5. This is adding and subtracting rational expressions, and in this video, this is our second video, we are going to be focusing on LCM, least common multiples, and we're going to be adding and subtracting rational numbers or rational expressions with unlike denominators. So, like with adding and subtracting fractions with unlike denominators, essentially, we are going to be focusing on creating like denominators by using the least common multiple, and we'll talk about that right now. So, if you are keeping up with your missing, which I hope you have been doing, if you look on the addition side of things, this flap right, oops, I totally moved everything. This flap right here has already been taken care of. You should have that already filled out, so ignore it. We're now going to be focused on the base, and all of this information, there's going to be a lot of problems and some practice problems to pay attention to for least common multiples. So you're going to be writing out steps for solving unlike denominators on the subtraction side of your page. So let's begin. So just like with fractions, you have to have denominators to add or subtract rational expressions with least common or with unlike denominators. To find a common denominator, it is helpful to find the least common multiple. The least common multiple of the given expressions is what we're going to need to find for 24a to the third and 4a. And I will show you exactly how to do that. We're going to move over to this side here. Oops, didn't need to do that. We're going to move over to this side here and play around with this concept right up here. So just like when we are adding 1/3 plus 1/4, we can't actually do any of the multiplication, essentially, or any of the addition. Essentially, what we need to do is we need to find a common denominator. A common denominator between 3 and 4 would be 12. That is the smallest number that works for both of those numbers. That is a multiple of both of those numbers. So 1/3 would be rewritten as 4/12, and 1/4 would be rewritten as 3/12. So our final answer would be 7/12. So we're doing the same sort of thing. Essentially, what we're doing with least common multiple is we are finding the smallest multiple of both of these numbers, and we're eventually going to think, well, if I were to put this as, or if we were to see this as a denominator with our rational expressions, I would be able to solve this rational expression by finding its least common denominator, or least common multiple. So here is our first step. We're going to play around with this. We have 24a to the third, and we have 4a. If you notice, I have lined them up vertically, so we have lots of room to play around with this. And when we look at least common multiples, it's really important that you actually pay attention to the prime factorization of all of those numbers. So if we look at a, or 4a, that one's probably the easiest to play around with. So we're going to play around with that first. We can write this as 2 times 2 times a. And if you notice, I left a big gap there, and you'll see why shortly. 24a to the third, we're going to break that up. And if we think about 24, that is essentially 8 times 3, or 8 is essentially 2 times 2 times 2. So that 24a to the third, we can write this as 2 times 2 times 2 times 3 times a times a times a. So we are now going to find like terms that can just kind of flow out of here. We now need to think vertically. We've just been pushing this stuff out horizontally. We've been expanding our numbers into prime factorization form. And what we're going to do now is find the LCM. We're going to find the least common multiple. The way to do that, and to make sure that we don't end up with lots of redundancies, is to say, if we have all of this stuff lined up, we can quite literally say we have 2 sets of 2s, so we can take 1. We have 2 sets of 2s here. We're going to take another. This one doesn't have a partner, so it needs to come down. Same with this 3. It needs to come down. We have a set of a's, so that's going to come down. And now we have 2 more sets of a's, or 2 more a's. So our least common multiple for 24a to the third and 4a is 24a to the third. You're like, but we had 24a to the third as one of our numbers. Well, if we think about it, 4 can go into 24 evenly, goes in 6 times, and a can go into a to the third evenly 3 times. So our least common multiple for this situation is going to be 24a to the third. Simple enough. Let's try another one. This is where things can get tricky. We have 2c squared times plus 10c plus 12, and then c squared plus 7c plus 12. So we're going to rewrite this out over here. We have 2c squared plus 10c plus 12, and we have c squared plus 7c plus 12. Now I know you're probably thinking as of right now, well, this other one was pretty easy to find the LCM. However, this seems a lot more complicated. And to find the LCM of this, it is a little bit more complicated. Essentially, we have to do bottoms up. We have to factor. We have to find GCFs. We need to do a little bit more work. We need to essentially break this problem down so it's a bunch of numbers multiplied by a bunch of numbers, just like we do with prime factorization. So we need to do that same thing here. 2c squared plus 10c plus 12. That can break down into 2, and then c squared plus 5c plus 6. After that, we can break that down even further, and we can say that is equal to 2 times c plus 2 times c plus 3. So that's how that one can be broken down. This other problem can be broken down into c plus 5. Wait, that's totally wrong. Wow, I totally messed it up. C plus 4 times c plus 3. So let's rewrite both of these so they're nice and vertical and standing on top of each other. We have 2 times c plus 2 over times c plus 3. And we have c plus 4 times c plus 3. So if we were to think about this, actually I should rewrite this. I'm going to rewrite this bottom part as this. Might as well line everything up the way we need to. C plus 4 over here. Looking at this, we essentially are now going to look vertically. We don't have any matches for the 2, so it needs to come down. We don't have any matches for this c plus 2, so it needs to come down. C plus 3 happens twice, so we only need one of them. And c plus 4 doesn't have any matches, so it's going to come down. So our least common multiple for this situation is going to be 2 times c plus 2 times c plus 3 times c plus 4. Now, you're probably thinking, why am I doing this, Miss Beardsley? Well, we're going to find out right now. So now that we know how to identify the least common multiple, you've just done a couple of problems with the least common multiple. We're going to actually go over to the subtraction side of things. Hopefully you took good notes on the other side. We're going to go over to the subtraction side of things, and I want you to keep the least common multiple side open. So you still have that addition flap open. You're looking at the base, and then the subtraction flap, you're going to look at the base of that, and we're going to add some problems to it. So we're going to be looking just right here. We already have this stuff on the flap taken care of if you watched the first video or if you were in class today. So now we're going on and practicing how to add or subtract rational numbers with unlike denominators. So there's 5 total steps. So pause the video, write these steps down, or 6 total steps. Pause the video, write these down, and write them small on this thing so that way you can practice a couple of problems also within this base part, unless you have some extra space on your actual foldable. So step number 1, we need to identify the least common multiple, the LCM. We need to figure out what that is. So you're only going to be looking at the denominator here, and that is going to dictate what you need to multiply by, essentially. After that, you're going to multiply each expression brought by an appropriate form of 1. Think about that. 1, so that each term has the LCM as its denominator. I'm going to walk us back to that whole concept of doing 1/4 plus 1/3. So technically, we need to get 12ths on the bottom of this. We know everything that is in the form of 12 will work for this particular situation. So we need to turn 1/4 into 12ths. The only way to do that is we need to multiply by an appropriate form of 1. So we're going to multiply the top by 3 and the bottom by 3. So that way the bottom becomes 12 and the top will become 3. As well, we're going to do the same thing with the 1/3. We're going to multiply the bottom by 4 and the top by 4. That is our appropriate form of 1 to get an equivalent denominator. Then after that, we can simply add it, and we get 7/12. Okay? So we're doing that same exact thing with our rational expressions, and you'll see this in more depth shortly. Then you're going to write each expression using the LCM, so you're going to essentially rewrite your expression as like 4/12 plus 3/12. You're going to add and subtract those numbers, combining like terms as needed, so you'd say 4 plus 3 equals 7. You'll factor if you need to, and you'll also simplify if you need to. So if 7/12 wasn't in simplest form, you could do a little bit of work to get it in simplest form. So let's do a little bit of work and see if we can figure some of these out. So we're adding and subtracting unlike denominators, and we're doing a little bit of practice. So here are those 2 practice problems that I talked about. This should be on the base of your subtraction flap, or of your subtraction foldable. So it's not on the flappy part, it's on the base. It's on the part that's stuck to your stuck to your notebook. So let's zoom in and figure this baby out. We have 3x over 6x squared plus 2x over 4x. So looking at this, we need to find, first things first, a least common multiple. Our least common multiple is based on our denominators. We have 6x squared and we have 4x. So let's break down 6x squared into its prime factored form. We have 2 times 3 times x times x. 4 we're going to do the same thing to. We can turn that into 2 times 2 times x. After that, we need to find what our least common multiple is. So we're going to bring down all of our different parts. We have 1x that doesn't have a pair. We have 2 x's that become a pair, so that we just need one of them. We have a 3. We have another 2. And we have 2 that are pairs. So we have 2 times 2 times 3 times x, which is equal to 2 times 2 is 4 times 3 is 12. And we have x squared. Now if we think about that, can 6 is 6x and 12x, are those related? Yep, you just have to multiply by 2 to get the 6x squared, or to get the 12x from the 6x squared. And then same with the 4x. We just need to multiply by 3x to be able to get the 12x squared. So now we are going to rewrite our equation. We have 3x over 6x squared, and I'm going to leave a little space here, and 2 plus 2x over 4x. I'm going to leave a little space again before I write my equal sign. I do that because we are going to multiply each side by an equivalent form of 1 in order to get our denominator to become 12x squared. So we've already talked about it a little bit. How do I get 6x squared to look like 12x squared? I need to multiply by 2, and if I multiply by 2 on the bottom, I need to do that on the top, otherwise I'm not keeping my fraction proportional, or we're not keeping our rational expression proportional. And we have the 2x over 4x, so we need to do the same thing. We need to multiply by an equivalent form of 1. So how do I get 4 to become 12? Well, I need to multiply by 3. How do I get x to become x squared? I need to multiply it by x. I'm going to do that on the top and the bottom. Now, let's do a little bit of multiplication to simplify all of this a little bit. We have 3x times 2, that becomes 6x. We have 6x squared times 2, which becomes 12x squared, exactly what we want. We have 2x times 3x, which is 6x squared. And then we have 4x times 3x, which is 12x squared. Now we just need to put everything together into one final rational expression so we can play around with this. We have 6x squared over, or 6x over 6x squared, or 12x squared plus 6x squared over 12x squared. So we can rewrite this as 6x plus 6x squared over a common denominator of 12x squared. From there, our last step, or our fifth step, was to do a little bit of factoring. And if we notice there's a GCF in both of our terms, our GCF is going to be 6x. So we can rewrite our top part of our expression as 6x times 1 plus x. And our bottom part is 12x squared. From there, we can do a little bit of simplification. Our final step, if I have 6 on top and 12 on the bottom, I can cross those babies out. 6 becomes 1, 12 becomes 2. As well, I have an extra x, so I can take out an x, and I can take out an x on the bottom. So our final answer for this equation is 1 plus x over 2x. So that would be our final answer for this equation. We were able to go through every single step, so I'm going to identify those once again. Our first step was to find the LCM, that's number 1. Our second step is to multiply by an equivalent 1. Our third step is to rewrite everything as that with that common denominator. Our fourth step is to combine things so we just have the common denominator and everything on top. Our fifth step is to factor, and our sixth step is to write it after it's been simplified. So we're going to do the same thing with one more problem, and it'll be nice and fun. So we have 1 over m minus 3 minus 5 over 3 minus m. Our denominators, if we look at this, m minus 3 and 3 minus m, those are opposite binomials. We know how to do this. This is opposite binomials. Now, we could do this problem one of two ways. We could multiply the bottom of this one by 3 minus m, and we can multiply the bottom of this one by m minus 3 and do the same thing on the top. Or we can make our life pretty darn easy by saying I can rewrite one of these denominators as the other just multiplied by a negative 1. So let's take this 3 minus m, because I always like saying variables first. I can rewrite this denominator as negative 1 times m minus 3. So now all we need to pay attention to is finding that LCM, and our LCM, our least common multiple, is going to be pretty easy to find. We have m minus 3 for one of our LCMs, and the other one is negative 1 times m minus 3. So since we already have an m minus 3, we have that for our part of our LCM, least common multiple. And our other part of our LCM is this negative 1. So we are going to now write our rational expression with an equivalent form of 1 multiplying everything. So our right hand side of our expression, that one's set. We have our LCM as our denominator, so we don't have to do very much work. On the other side of things, though, on the right hand side or on the left hand side, we don't have an equivalent form of that expression. So we need to multiply by an equivalent form of the denominator, an equivalent form of 1. So the only part of that expression that we are missing is the negative 1 aspect of it. So we're going to multiply the top and the bottom by negative 1. And if we do that, we can rewrite 1 times negative 1 as negative 1, and the bottom we can rewrite as that negative 1 times m minus 3, and we still have our other expression of minus 5 over negative 1 times m minus 3. We have a common denominator, so we can rewrite everything with that new denominator, and then we have negative 1 minus 5 as our numerator. Negative 1 minus 5 equals a negative 6. We have negative 1 times m minus 3 on the bottom. So the next thing that we need to do is just simplify. So the top and the bottom, they're both negative, so we can rewrite them as positive. So this top is going to look like 6, and the bottom, 1 times m minus 3 is just simply m minus 3. So there is our final answer. Play around with this whole concept of finding a common denominator. If you have any questions, as always, please call, email, text, whatever you need to do to be able to get the information you need. There are a couple of videos for Khan Academy on this exact same topic as well, so don't forget that those are linked to our class website. I hope this helps, and I hope you have a wonderful weekend. We only have 5 more academic days of school left. Ciao.